We know the derivative of sine x. We know the derivative of cosine x. If you recall, I'll just put them here. The derivative of sine x is cosine of x, and the derivative of cosine of x we learned is negative sine x. Okay. How are we going to find the derivative for tangent x? All right, we are not going to do this by graphing. We're not going to graph tangent x and look at those things. That's not a good way to approach it. Here's what we're going to do. Remember that tangent x is sine x over cosine of x, right? I mean, and we could do something similar for any of the other the three remaining trig functions. They're all come back to sine x and cos x. So if we want to know the derivative for tangent x, then we can think of it as sine x over cos x. And guess what? Let's use the quotient rule. Hey, we know those. No problem. Here it is. Let's talk through it. Applying the quotient rule to sine x over cos x, f prime here would equal, well, it's low. D high, well, derivative sine x is cos x, minus high times d low, well, derivative cos x, negative sine x. Okay. And of course, that's all divided by the original low squared, cosine x quantity squared. Now we're talking. Now we got some power. Okay. Let's simplify this. All right, so we've got cosine times cosine, sine times sine, and negatives going on there. Here's our numerator. F prime of x equals cosine squared x plus sine squared x all over cosine squared x. Okay, that's cleaning up fairly nice. Hey, do you guys remember the trig identity? It's the number one identity. It's probably the first one you even learned. Cosine squared x plus sine squared x, what that simplifies to. You might remember this all equals 1. For any value of x, cosine x squared x plus sine squared x will always equal 1. So we got 1 over cosine squared x. And if that's what we're looking at, hey, let's just think of it as secant squared x. Do that reciprocal. All right. That's your derivative of tangent. Okay, at this point, I'm going to write out the derivatives of all 6 trig functions. Let's just show them to you. We're going to look at these for a couple minutes, study them. All right. At the end of the day, you don't need to know, it's not so much about proofs. Of course, in some of the homework questions, actually, we proved this one. They'll ask you to prove cosecant x, maybe secant x, maybe cotangent. I forget what I assigned and what I didn't. But we could prove any of these 3 in the same way that we did tangent, if we think of it as the quotient of 1 over sine or 1 over cosine. Okay. So here they are. Right, we know derivative of sine x is cosine x, derivative of cosine x, negative sine x, and we just learned the derivative of tangent x is secant squared x. So what are the other 3? There are a little bit more to them, like there's 2 parts. The derivative of cosecant x is negative cosecant x cotangent x. Okay. The derivative of secant x is secant x tangent x. And the derivative of cotangent x is negative cosecant squared x. Now, I guess there's no easy way to say it. You're going to have to just memorize these. These are like 6 different kind of independent rules for each of these specific cases. So there you are. You just got to know them. That said, there are a couple of patterns going on that will make it a lot easier to memorize these. Also, the more problems that you do, just the repetition really helps you to remember them. But let's point out these patterns because I think that is super, super helpful. So I like, for one, as you look, some of these are positive, some of these are negative. Right? Which ones are positive? Which ones are negative? Maybe even start, which ones are negatives? And people usually say, it's all of the cos, cosine, cosecant, cotangent. Those are the negatives. And the non-cos are the positives. And okay, that's one nice pattern. So you know if it's a co, it's got to be a negative. If it's not, it's got to be a positive. All right, that's really helpful. Okay. What else? There's another pattern. I like to think of these friendships between the trig functions. It's helpful to remember things to give, these functions like personalities, okay? And they're relational, right? So I like to think of sine and cosine being friends, right? Because the derivative is this, and the derivative of cosine is sine, but it's a cos, so it's negative, okay? So it's just its friend, and we know how the negative thing works too. What are some of the other friendships? Tangent and secant are friends. Well, certainly the derivative of tangent is secant squared, but also the derivative of secant is secant tangent. Now, in this case, the pattern there is not identical, but there's a friendship. We can see that. Okay, and then cosecant and cotangent are friends. So we know it's co, so it's negative, and then it's got itself and its friend. And then cotangent, we know it's negative, and it's its friend squared. And then the last thing, and you maybe even see this already, the derivative of tangent is very similar to the derivative of cotangent, right? It's its friend squared. And its friend squared, of course, that's a co, so also negative, right? And then the derivative of secant and cosecant, very similar. It's itself and its friend. Itself and its friend with the negative. So I would say there's like these three patterns, and if you remember these three patterns, then you'll get it and you can piece it together. A lot of people will remember sine and cosine. I mean, those are the easiest, but then they'll just remember tangent and secant. So they'll know derivative tangent, secant squared, derivative secant, secant x, tangent x. And they won't need to remember cosecant and cotangent because they'll just remember how secant works or how tangent works, and then they'll know to throw the negative on there as well. So hopefully that's helpful. Whatever means you need to memorize it, I think that's a fun way to do it. Okay, where to go from here? Just a couple of examples. There's really not much else to chat about. Now that we know the trig derivatives, we can combine these with all the other rules. So we can combine them with product rule, with quotient rule. We can throw powers of x in there, e. Okay, so it's all gets thrown into the bag and mixed around, and you pull one out, and that's the problem you have to do, right? So just to finish off this section, lecture-wise, find the derivative. We're going to begin with something like this. Get some practice in here. F of x equals 4 secant x plus cotangent x cosine x. And okay, they're just throwing everything at us. Also, you notice 4 secant x, that's a constant multiple. So we'll handle it the way we need to. Over here, we have a product. So we need product rule. Okay, let's do it. I've got it all right here. Okay, so 4 secant x, well, the 4 simply carries down. And the derivative of secant x, tangent x. Okay, plus, we've got a product, so derivative of the first times the second derivative there, negative cosecant squared, and then we copy, plus copy cotangent x times that derivative, negative sine x. And you know what? If this was on a test and you wanted to circle this answer right here as the non-simplified version, I think that's wonderful. I went ahead, I think this one, there's really very little to do, just the negative signs. So I went ahead and simplified it. You know, the negative comes out, and I can, you know, get rid of the parentheses and stuff, and that negative comes out here. And I think that's pretty minimal. So I just went ahead and did it. By the way, sometimes students, you know, when it comes to simplifying these, when you do need to simplify them, some students, they really get carried away with all of the different trig properties and what cancels, and how to really clean it up really well. And I think, you know, taking the course trig, when you first learned this, that was really ingrained in us. You know, use the identities, simplify this thing down as much as you can. I'm just going to tell you the way we're going to use trig here in this course. That's not necessary, and I would advise against that sort of thing. Don't even, just, you know, whatever it is, if it's something really obvious, I mean, like negative signs, or you know, sometimes cosine squared x plus sine squared x comes up, and you know that's equal to 1, right? If it's really obvious, go ahead and do it, but don't think very hard. Don't spend more than 30 seconds at the most cleaning these up. Okay, in this example here, the sine, if you think of this cotangent as cosine x over sine x, okay, this would be something that maybe some people would notice, and, you know, you could just write this whole thing as cosine x. You know, that's great. Don't go any further than that. Don't start to do any kinds of crazy stuff with the rest of it. Leave it alone. And even if you don't do that, that's fine. Just leave it like this. Don't go down the rabbit hole. Okay. That's really nice. Oh, this was part A, my mistake. Let's check out part B. Y equals 1 minus sine x over 2x to the 7th. And what do we have here? We've got a quotient rule. Hey, we've got a power of x. We've got a sine. We've got a 1. Let's go for it. It's always good practice, you know, especially quotient rule, product rule, recognizing them, performing that, you know, those formulas. So y prime, all right, we got low. D high, okay, so the 1 would be 0. The sine would be cosine, and then that negative is like a constant multiple. So negative cosine x right there, low d high, minus high d low, all over the low squared. If this was a test, hey, just circle it right here. You don't have to go any further if you're not simplifying. But if you wanted to, it's worth the practice. You know, there's not a whole lot to do here. I think that's what I've got. So negative 2x to the 7th cosine x, minus 14x to the 6th, and then plus 14x to the 6th sine x. And let's go ahead and square that. 4x to the 14. You know, it really, there's your simplified. There's not much to do. Okay, lots more examples in the homework. Go check it out. That's it for 3.3.